So today, this is college physics. So if you're not in college physics, you probably want a different class. Today we're going to do the syllabus, and I'm going to give a little math quiz that isn't scored or anything, but it's just so there. Here we teach like 3 or maybe you'd even say 4 different levels of physics based on like the mathematical requirements. And so I'm going to do a little math quiz so you can get a sense of where your math skills are compared to the kind of stuff we're going to see in this class. Most people won't be able to do all the problems, but the idea is that it should all look familiar to you. Hopefully you should see these problems and be like, okay, I kind of remember what class we did that in. I could go back and figure out how to do it. Mostly it's just for the people who look at it and they're like, I have never seen this before. Then this might be the wrong physics class. But anyway, so we're going to do the syllabus, that math quiz, and then with whatever time we have left, we'll start talking about units. That's the first, units and measurements and things like that. Okay, so the first thing most important skill you need for this class is to be able to get into D2L. Everything's on D2L. So if you've taken classes here before, I'm sure you're very used to it, but if you're new to Normandale, the way you get to it, go to the Normandale main web page, and there's a place right in the top right that says D2L. Log in using your star ID and password, the same stuff you use to log into everything with Normandale. If you have trouble logging in, talk to me. I can show you where tech support is, and they can get you logged in quickly, I'm sure. And once you log into D2L, I think this is the teacher page, but I think yours probably looks pretty similar. All the classes you're taking will be lined up on the right side. And so we'll go to college physics. And once you get into any individual class, once you get into college physics, there'll be a list of news items here that I'm going to plan on updating whenever I put something new on D2L or anything you need to know. So it's just going to little by little scroll down that as the semester goes. Pretty much everything that you're going to need for this class is going to be in the content section. So go to materials, content. And then there's a few different categories. Course information, that's where the syllabus is. And then there's practice problems and practice problem solutions. And then there's old lecture notes. So I'll talk about that in a second. And then all of our labs are going to be posted on here. There aren't any up yet. The lab for this week is just going to be, we're going to do this pre-test, post-test thing that sort of tests how well you pick up kind of intuitive ideas of physics over the semester. And so we're going to do the pre-test this week, today, and the people who have lab today will do it tonight, and then Wednesday we'll also do it. Most of those questions are going to, most people here aren't going to probably do too well on that test in the pre-test. If you haven't taken physics before, there's not, some of the questions you might have a just sort of natural sense about. But anyways, we're going to take this half-hour test today. The lab should only take half an hour, maybe 45 minutes. Then you can leave. But at the end of the semester, we'll take a post-test, and usually the scores improve quite a bit. And we use that to figure out what kind of changes to make in the class to just sort of the class itself is pretty mathematical, but we're trying to make it so that people also pick up these sort of intuitive understandings that I think are really important for how you are able to use this physics knowledge as you go forward. Okay, so as you can see, I am giving this lecture on a computer, mostly because I'm lazy and I don't like to stand up. But also, a small part of it is that if I do it on a computer, I can create PDFs of my lecture notes. So this is the kind of thing that, so after every lecture, I'm going to post PDFs of what I talked about. It's going to look like this. This is just some random day from the last time I taught this class, just PDFs of everything that I write. And I'm also recording video as I talk. And so let me show you a little bit about what that video looks like. The idea here is if you ever miss a class or if you ever want to go back and some topic wasn't clear or whatever the first time, you can go watch the video, look at the notes, get a second crack at it, and hopefully that'll help. So okay, if you go to YouTube and type in Guy O'Lakin, that's me. There are playlists for all the different classes. Okay, here's College Physics 1 from, I guess, the last time I did this on the computer was 2013. But if you go in here,
is College Physics. College Physics is broken up into two classes, two semesters.
one where we're
the first semester
material.
All right, so
you can't hear this too well because it's just
the
coming
first
off my
thing
computer.
is
I don't have it plugged into sound.
Let's
but
be clear about the task.
Here's what you'll
Fresher about what we're doing.
let's see.
So I'm sort
so
of
you can see the pen up there.
starting to set us
I
up
write
for
it'll write up there. Basically, you'll just be like you're watching the whiteboard or something.
maybe the second
I don't
most
know.
important
It's a nice thing
equation
to
in
have
this
handy,
class, which is
especially
Newton's
if you
third
miss a
law.
class.
Newton's first law sucks. I don't even talk about it. It's so on person by scale.
Okay. So those are all the categories in D2L. Practice problems and solutions, those are all the problems that you're going to be responsible for during this class. They're already posted, so you can look through those if you want. But okay, what we want to do right now is go through the syllabus. So the syllabus is under course information. Well. How about this? Okay. All right, this is College Physics 1. The math requirement is college algebra. There are 5 sections this semester. And so one thing that's nice about that is if you ever miss a class or a lab and you have a little flexibility in your schedule, you can go to the corresponding class or lab at a different time. We'll go through and talk about lab requirements and everything in this class, but you can't miss many labs and still pass this class. So if there's ever a time that you can't make it to lab, you can look at all the 4 other times that it's offered during the week and get your lab credit for the week that way. There are 3 sections during the day and then 2 sections at night. So this has all the information that you need to, if you ever need to make it to another class. Or also for exams, sometimes people find it helpful. You don't want to miss exams. So if there's ever a time that you can't make it to this class, but you can make it to the day class, can rearrange your work schedule or whatever, make it to the day class, that option's available to you also. The locations, all of the labs are in the same room. 1324, which is just right next door over here. The day class lecture is right next door on the other side, so it's easy to find all this stuff. It's just a slightly bigger room. My name's Guy O'Lakin. I have a PhD in engineering, not physics, but until you get into sort of the crazy stuff, 20th century physics, it's all pretty much the same. So everything I tell you is going to be right, or that's my goal, My office is 2302 upstairs. The stairs right down here, just right at the top of the stairs, that's my office. And then this lists the office hours. But the way I'm going to do most of my office hours is sort of like a study hall. So I'm going to find a lab room that's available during these times. And then anybody who is able to make it for the office hours can come and just sit in the lab. I'll be in there. Other students will be in there. You can work on stuff. I'm there if you have any questions. It works out pretty nice. So like Monday and Wednesdays before class, if you have the flexibility in your schedule, I think you'd be happy getting into that habit. The people who have done that in the past have definitely done better on average than the people who've not. I guess that's not a big surprise because it's time you're spending working on stuff, but it seems to help out. My email is listed. That's probably the best way to get a hold of me. My phone number is also listed, but I don't have a phone in my office. There is voicemail. And it comes to I get an email that says, I got a phone call, and then so I can call you back or whatever, but email is probably the quickest way to get a hold of me. The materials that you need for the class, you need a good calculator that does sine and cosine. I'd be happy, and actually right below here are some recommendations for textbooks. But we're not going to use a textbook in this class. Everything you need to know is going to come straight from the lecture. And it has been my strong experience that when people, if people have been struggling in the class and so they've asked for outside resources and they've started reading through this other textbook that I recommend or whatever, it's not been a good way to get back on track. I think your best bet for doing well in this class is just to try to understand everything I say in class. And if you don't understand something, come talk to me about it. That's just, my lectures are designed to get you ready for the tests that I write and the homework that I write. And the textbooks are designed towards whatever that guy thinks should be the tests. You know what I mean? So, so I think using outside resources is a super valuable thing. But really, I would recommend not doing it until this class is over, or at least not thinking of it as like a part of getting ready for this class. You know what I mean? But the two recommendations I have for textbooks, one is Physics by Gian Coley. That's the textbook that they use in other sections of college physics here. And then Sham's Outline of College Physics. How many people here have ever seen Sham's Outlines? They're the greatest thing. I mean, every single science class you take from now on, you should buy the Sham's Outline for it. It costs $15. It's paperback, like newsprint. Each one has 1,000 problems with answers. So if you're ever, I know a lot of the people who take this class are thinking of doing pre-med and dental school and vet school and stuff. And for a lot of those, you're going to have to take standardized tests where you're going to have to know some physics. Sham's Outline is a great resource for getting ready for that kind of thing. I bet I have 40 Sham's Outlines in my basement, some of which I've read. But even the ones you don't read, it's only $15. The math prerequisite is college algebra. Like I said, everything that all the materials that you need for this class are going to be given on D2L. And then the topics, I'm not going to go through this whole list of topics, but mainly, I guess, what you should know about this class is that the first year of physics is broken up. Physics 1 and Physics 2, the way it's sort of broken up always is Physics 1 has to do with the motion of bodies, forces. Essentially, you can think of it as the kind of things you can see. You're used to the way objects fly through the air, and if you roll something down a ramp, you're used to the way it speeds up as it rolls down. So that is always the first semester of physics, figuring out how to do those calculations. And then the second semester of physics is mainly electricity and magnetism. But there's a list of the topics there. Let's see. So if you have any questions about those, feel free to ask me about it. The grading for this class is the A's go down to 92, the B's go down to 82, C's go down to 70, and then don't be below that. So a lot of times people ask why, 90, 80, 70 is a more common set of grade cutoffs. I think I designed this class with the intention of making it easy to follow, and when you get to the tests, there won't be any big surprises on the tests. The questions will look like the questions that you've done on the assignments, and so I think a lot of the things that in other classes make it harder to score as high are removed in this class, and so I think you'll find if you put in the amount of time that you're supposed to put in for a 3-credit class or 4-credit class, I guess, with lab. I don't think you'll find those cutoffs to be, that hard compared to other classes. I think I would guess, if anything, I probably give more A's and more B's slightly than other people teaching this class, even though their grade cutoffs are lower. So just don't be freaked out about the higher looking grade cutoffs. The grade will be determined this way. Exams are going to be 70%. That's another thing that makes people nervous, I know, because people have various levels of comfort taking exams and stuff. Lecture quizzes, 20%, lab exams, 10%. So if you look at the way the grade's broken down, all of the entire grade is based on tests of some kind. There aren't any projects or assignments that you hand in, and that makes people nervous. But like I said, these exams and quizzes and lab exams are going to be so much like the assignments that you've been doing that I think you'll find, and so they're a lot like the assignments you've been doing, and I think you'll find that it's not a very stressful, if you've done the work, it's not a very stressful kind of test. I'm just basically asking you to show that you understood the stuff that you did. I also make a major effort to not make the tests real, races against the clock. This class is 80 minutes long. For a test, you'll have 90 minutes because there's that 10-minute passing period at the end. I always write these tests with the intention of half of the class having turned in the test and be gone within an hour. That's the way I think about it. So half of the class will be gone after an hour. The other half will use the last half hour or whatever. But I think you'll find that that it's you can take the test in sort of a leisurely way and it'll be fine. All right, any questions about the grading or the grade breakdown? Now I'm gonna go in detail into all these different categories and talk about like what the exams are like, when they're gonna be, that sort of thing. Any questions about the grading before I do that? Yep.
So you keep referring to assignments, but there's like not assignments in your grade group?
Yeah, so the assignments are those practice problems that I pointed out on D2L. So there's a whole list of, I don't know how many, probably a total of 100 problems or something. You don't turn it in, but they're going to be, your understanding of those problems is going to be evaluated in a couple ways. And I'm going to, in the news on D2L, after each class, I'm going to tell you which numbers you're ready to work on now after that lecture and stuff. So you won't turn them in, but other than that, it's just the same as assignments in other classes. Any other questions about the grading? Okay. So first, talking about those practice problems. They're designed to be similar in approach to the questions that you're going to see on the tests. You're going to want to do them more than once. Your goal with each of these problems is you want to be able to explain how to do that problem to somebody else. So it's not a question, like you're not going to want to try to memorize how to do these problems, but you need to understand at each point in the problem, in solving the problem, why did I make this decision? Why is this negative? Why is this? And if you can get to the point with these problems where you could explain to someone why you did each one of these steps, I think you'll feel very comfortable on the tests. Okay. There are solutions to all of the practice problems. So one thing I would recommend is try to do the problems without looking at the solutions, and then use the solutions either to give yourself a little nudge if you get stuck, and if you get all the way through it, just to look at your answer and make sure that you're thinking about it the right way. I think getting into the habit of looking at the solution before you've made a serious effort to work through the problem just doesn't seem to be a very good way to learn the material. So I wouldn't recommend doing that, but you can do what you want with it. Okay, the exams. There will be 5 exams. They're all worth the same amount, so the total for all 5 exams is 70%. That means each one is worth 14%, which isn't. So none of these exams are like super, super high stakes or anything. There will not be any makeup exams exactly. So so say that you miss a test. You have to work late, or for whatever reason you miss a test. Unless it's a medical emergency or a death in the family or some major thing, I'm not going to give any makeups at that time. But there is a policy that lets you make up one missed exam. So basically, you want to be at all the tests. If you can't make it to the test, for the night class, you should look into the possibility of getting to the test during the other lecture. See if you can do that. That would fix the problem. But here's the way that I do that one makeup exam. After you take the 5th exam, which is during our final period, as long as that score on your 5th exam is higher than at least one of the other previous scores, I'll replace the lowest previous score with that exam 5. So that exam 5 can count double. Okay, so if you miss a test, that ends up being your makeup. So if you miss exam 2, then you take exam 5, you get an 86 on it. Your grade shows an 86 for exam 5 and an 86 for exam 2. Okay. If you don't miss any exams, then it gives you a little flexibility to, you can have one exam that doesn't go very well and it doesn't have to affect your grade. Like, say exam 2 you scored 64 on it or something. Then exam 5 you score 86. That 86 replaces the 64. And so if you can make it to all the exams, that's a nice little insurance policy that's available. One important thing about the exams that isn't super common, I guess, or at least not every instructor does this. Every exam is going to be cumulative up to that point in the class. So they're not going to be. It's not going to be like exam 2 only covers the material from exam 1 until exam 2. Everything's going to be cumulative the whole way. And so the way to prepare for that is just to keep looking back over those old practice problems through the whole semester. Okay. And that's going to be sort of a theme with the way I grade all of this stuff. Everything's just going to keep being cumulative. I want you to keep reviewing the old stuff as you add the new stuff. I think it's a better way to remember what you're doing later, 6 months from the end of the class or whatever. You've just spent more time thinking about it. It just sticks better. So here's the exam schedule. You can look through that. Like I said, with this policy of not doing makeups, except besides this one makeup at the end of the semester, you should probably look at this schedule and make sure that you can make it to those. If you can't, we can talk about it. Maybe there's something we can do, but maybe this just isn't the semester that you can take this class, But it lists when the exams are given for the night class and when the exams are given for the day class, so you can figure out which one works better for you and go to whichever one works. All right, any questions about the tests? All right, so exams are 70% of your grade. Lecture quizzes are 20% of your grade. I didn't give a schedule for this. I should think about that and give you a schedule. But we're going to do lecture quizzes every 2 weeks. So at the end of one class every 2 weeks, we'll do like a 15, 20-minute kind of quiz. The exams are all based on problem solving. The quizzes are different. The quizzes are just meant to make sure that you're going back, reviewing your notes, trying to remember what I said. I just want you to spend some time reading back through the notes, reviewing the stuff. I want you to remember what I said. The way I think about it is in a lot of classes, most classes you have a textbook, you're given reading assignments like read chapter 1 before Friday or whatever. It's a lot of pages of reading. In this class, there's no reading. There's no book. The only material you're responsible for is what I say, and that's not really very much. Like, look how much time I've already wasted saying nothing. So I think it's pretty reasonable to expect that you should know the stuff that I say pretty well. I'm trying to condense. I've tried really hard to take out the things that I think are important and put that in your notes, and so I just want you to review that stuff. Oh, this is old. I will give you an updated version of this lecture quizzes stuff. It says that the lecture quizzes are on the first page of the exam. That's not how I do it anymore. So we're gonna do those quizzes as a separate thing every 2 weeks. So there'll be a total of 8 of those or so. Those add up to 20% of your grade, so that's, what, 2.5%, I think. Each lecture quiz is worth 2.5% of your grade. So none of them are very, like, really that important on their own, but they add up. Any questions? Lecture quizzes are also cumulative. So that does make it a little more challenging, because as the semester goes on, it's just a lot of material that you have to keep. But I just want you to keep skimming back through your notes, reminding yourself, like when I picture the ideal state of affairs, I picture you know how you have books that you've learned really well, where you're like, okay, yeah, I remember at the top of a page it said this, and then on the next page it said this, and there was, like, I think you should skim through your notes, read through your notes enough that you have that kind of sense of when things were said in the class. Lab exams. So this is my second time teaching this class with this new format of labs that I've been working on. These labs, they're not even, very few of them are really what you would think of as a lab, but they're just exercises in thinking about, like, the intuitive parts of what's happening with physics, and just giving you tools to think about it in a sort of a disciplined way. I think an intuitive understanding of what's going on is important for everybody, and I think it might be even more important for a class like this, where I think most of you are probably planning to go into some area of science, but most of you are not planning to go into physics. And so you're not gonna have later physics classes that make you refresh these calculation skills, and eventually those are going to fade away. There's just no way to remember how to do calculations if you don't keep doing it. But hopefully this intuitive sense of what's going on, this way of kind of looking at the world and imagining, predicting what's going to happen in just a sort of a qualitative way, hopefully that's the kind of thing that can stick with you, and the kind of thing that can help you in later classes, when physics principles come up later in your bio classes or chemistry classes and that kind of thing. So that's what the labs are about. There are going to be 3 lab exams, so these lab exams are going to be based on the material that we cover in labs. They're going to be cumulative again, so you're going to want to go back and review old labs all the way through the semester. Since lab exams in total are only worth 10% of your grade, each of these lab exams is only 3 1/3% of your grade. So, again, each one doesn't have a big effect on anything, but they add up. And I did give a schedule for the lab exams. So again, you want to, if you have a calendar written out for the semester, you probably want to look at this now, make sure that you can make it to all those tests. If you can't, come talk to me. Maybe we can work something out. Question?
Are those be taken in lab?
In lab, yes. Yes, in lab. So yeah, really, the labs and the lectures are sort of separate from each other, but these intuitive ideas, of course, come up in the material, and they'll sort of reinforce each other somewhat. Any other questions about lab exams? And then there's no part of the grade that is based on the labs themselves, but you do have to, basically you have to come to all the labs. You can miss 2, but if you miss a third one, you fail the class, so be careful with that. I know like what a lot of people do is just come to all of them, and then at the end of the semester you have a lab or 2 labs that you can skip. I'm sure at the end of the semester all of you have plenty of other stuff you could do with your time or whatever, so it's sort of a nice thing to have free. Okay, any questions about that? Okay, cheating. In this class, that the only thing that can happen is copying the work of someone sitting next to you. It says in here what I do when someone gets caught doing that, and it does happen sometimes. I think some students maybe are surprised to find out how easy it is to tell when you're doing that. So just don't do it. That's not a good strategy for for getting through school. And then I also have this thing in here. Really, this doesn't apply to you at all. The stuff about acceptable group work, and since you're not turning in any projects or assignments, that doesn't have anything to do with this class. I would recommend as much as you can. I mean, I know everyone's schedules are busy and everything, but anytime you can spend working together on problems seems to help a lot. If you can get in the habit of meeting with other people in the class, outside of class, regularly, I think you'll be happy. And not just for this class, but I also think it's a good skill to develop as you go on. It's going to be an important thing if you go to grad school. It's going to be an important thing after you're done with school and you go to work. So I would recommend working with other people pretty much as much as you can fit in. Attendance is not taken in the class. It is in the lab, but not in the class. So, the lectures are all videoed, and the notes are all provided. So I think a lot of people feel like they get a lot out of coming to class, and so I'm not trying to say don't come to class, but if there's ever a time that you feel like you're just in a headspace where you can't pay attention or whatever, don't feel guilty about it. Just don't come to class, do what you need to do, and then go to the video later, take notes on it the same way you would in class, use it the same way you would if you were at class, and that'll work fine. I've had many students. I've had students get into trouble because they didn't come to class too. So I don't want to. But I've had students get A's in the class and just they only come to lectures on the days that there are tests and stuff, and that's fine with me. It's not like one of those things where like I say it's all right, but deep down, like. And, okay, here's the phone number that tells you if class is canceled. All right. Oh, there's a little note on here about the Office for Students with Disabilities, and that's a really nice service that's provided by the school. I think the way, I'm sure they do a lot of things, but the way I've seen it used the most often is students who have different kinds of learning disabilities or, just for any reason have trouble with time. You can go take or trouble with, doing things quickly, or also trouble with noise in the classroom. You can go take the tests in the OSD office. They'll proctor the exams. They'll figure out like whether you need extra time for your exam or whatever. And it's a great service, and so if you are concerned that you might have any trouble getting through tests in the allotted time, like that's been an issue that's come up over and over again, or if you get really easily distracted with the noise of people shuffling around in class or whatever, just contact them, and it can't hurt to see what they have to say about it. Yeah. All right. Any questions about the class in general or the syllabus? All right.
I have a question
Yeah.
about how you grade.
Mhm.
Do you kind of give half credit?
Oh, yeah, for
How
sure.
far you get in the
Yes.
Okay, so it's not all or nothing.
No, it's definitely not all or nothing. And if there are a lot of times where people get the wrong answer and get full credit on the problem, like if these problems are just meant for me to see that you know how to do the problem. And if you say 6 times 2 is 40 or whatever, like I don't really care about that kind of stuff too much. I just want to see you go through the method that shows that you understand the material, But yeah, partial credit, a lot of partial credit. Any other questions? Okay. So now let me write down these 5 questions. This is the math quiz I was talking about. It's like I said before, it's not going to be graded. I'm going to collect them because I want to see sort of overall what people in the class are, what makes sense to people and what doesn't. You can put your name on it or not put your name on it. I don't care about that. But I'm going to give you these problems, and then we're going to take, 15 minutes or something to let you try to work through it. Yeah, sure. Yep. Okay, so here's the math quiz. And these questions are sort of, they're the kind of questions the kind of problems that we'll have to do in this class, maybe sort of on the harder end of math problems that you'll have to do in this class. So if you can do all these now, you're way ahead of the curve. If you recognize all of them and can do 2 of them or whatever, that's kind of where I'm hoping you'll be. If it all looks foreign, then we should talk. Okay, so the first one. Plot the function y equals x squared. So just draw a graph of that function. Second, calculate the slope of the line that goes from the coordinates 1, 2 to the coordinates 4, 3. Third, simplify this expression. So it's a fraction. In the numerator, it's a b squared c squared. And in the denominator, it's b to the 4th a square root of c. So you're not going to be able to come up with a number for that. You're just going to come up with a simpler expression in terms of a, b, and c. Fourth, solve this expression for a. So we have a squared bc is equal to 4c plus b squared c squared. And so again, for this one, you're not going to come up with a number for a. You're going to come up with a equal to some jumble of b's and c's. Okay. And then the last one, solve this system of equations. X1 plus X2 is equal to 50. So that's equation 1. And equation 2 says 2x1 minus 3x2 is equal to negative 10. I'm always making marks on this screen that I don't mean to because I'm left-handed, and life sucks when you're left-handed. Okay, so let's take, I don't remember how long this takes, maybe at least 10 minutes. See if you can work through these. I'm going to collect these at the end. You don't have to put your name on it, like I said, but just take some time to think through it, see if you can remind yourself how to do this stuff, and then I'll go through the solutions after you have a little time. All right, so the first one, we're plotting that function y equals x squared. If you don't recognize what that function is, you can just choose a bunch of x values, square them, that gives you the y value, and then plot out those points. So, like for example, when x is equal to 0, y is equal to 0 squared, so that's a point on the graph. When x is equal to 1, y is equal to 1 squared, so 1, 1 is a point on the graph. That's also if x is equal to negative 1, so over here, negative 1 squared is also 1, so this is also a point on the graph. If x is equal to 2, 2 squared is 4, so y is equal to 4. 1, 2, 3, 4. So that's a point on the graph. If x is equal to negative 2 squared is 4, so this is a point. And you could keep doing that until you saw the shape of it. It'll end up being a shape like that, a parabola. And that actually is a function that's going to, parabola. That's a function that's going to be pretty common in physics. If you plot the motion of an object when it's in any kind of projectile motion, you'll get a parabolic shape like this. So we'll deal with these squared functions a lot. Then the second one is the slope. So let me draw these 2 points first. So if there's the coordinate system, we have a point 1, 2. So that's like our starting point. And then we have a point 1, 2, 3, 4, 3. So that's our ending point. And we want to calculate, we want to calculate the slope of the line Yes. We want to calculate the slope of that line. Okay, so slope is rise over run. And so if you figure out how much height it gains, put that in the numerator, and then figure out how much it moves horizontally, put that in the denominator. Left-handed. Okay, so the rise. Its destination is 3 for the y position. Its starting y position is 2. Okay, so that gives you the rise. Its destination x position is 4, and its starting x position is 1. So that gives you the run. And so we have 1/3. Yeah. Number 3. So we have to simplify this thing. I'm going to write it. So I had it as ab squared c squared over the quantity b to the 4th a square root of c. I'm going to write it as a times b, b squared, you know, is b, times c, and in the denominator we have b times b times b times b, that's b to the 4th, times a, times the square root of c is c to the 1/2. Actually, let me do it like this. We'll call that square root of c. And I'm going to think of this last c here as square root of c times square root of c. You know, c is the square of the square root of c. And now we can just look for what cancels. Those a's cancel. 2 of those b's on the top cancel with 2 of the b's in the denominator. The square root of c cancels 1 square root of c. And so what we have left is c times the square root of c over b times b. And then we can simplify that a little bit. The square root of c, another way you can think of that is c to the 1/2. And so this is c to the 1 times c to the 1/2 over b squared. And then the last thing is, what do you get when you have two numbers with different exponents in the same base? How do I do that multiplication? You add the exponents. Yeah, so this is c to the 3/2 power over b squared. Yep.
For that one, first one, let's say if I use c over b squared too, would that be still count or
C over, what was it?
b squared too? Like take off the b over 2.
B times,
Like I have a over,
oh, you had the,
you just c over b squared 2.
there are a bunch of ways. I can't quite follow what you did there, but there are a bunch of ways to do it, and I just want you to figure out whether you remember these exponent rules and that kind of thing. So
I'm just
So-
saying that if I at least if I
Yes.
feel, would it be still count?
yes, yes. Okay, number 4. So we have a squared bc is equal to 4c plus b squared c squared. Okay, so we want to get a by itself because we're trying to solve for a. So we'll divide both sides by bc, and we get a squared is equal to this divided by bc. And now, to get a by itself, we're going to take the square root of both sides. So a is equal to the square root of all of this. And then there's one more thing, the thing that people always leave off. Always. Yeah. So like say a is equal to -2, then a squared is equal to 4. Say a is equal to +2, then a squared is equal to 4 also. They're the same thing. And so both of these two possibilities have to be accounted for. Yep.
Wouldn't the c in the numerator cancel one of the 4c?
Yes, yep, for sure. And so, yeah, with these simplify ones, there probably are some rules like that we learned a long time ago about, like, you have to do this to have it completely simplified. This was all, if you could follow steps like this, that's great. So what would it be? Square root of 4 plus b squared c divided by b square root. Yes. And then the last one, the system of equations. So we have x1 plus x2 is equal to 50. And then 2x1 minus 3x2 is equal to -10. There's a few ways you can do this. The substitution always works. So that's what I recommend, I guess. So we're going to isolate one of these variables from one of the equations, and then we're going to plug that back into the second equation. So this first equation says x1 is equal to 50 minus x2. And then I'm going to combine those two. Now I can, since 50 minus x2 is equal to x1, I can put that into the second equation in place of x1. So we have 2 times the quantity 50 minus x2 minus 3x2 is equal to -10. And so 100 minus 2x2 minus 3x2 is equal to -10. So -5x2 is equal to -110. And so x2 is equal to 22.5. Yeah. And then once we have this, if you've done it right, every other equation that you have along the way is true. So just look for whichever one helps you get x1 the easiest. So like plug it in here. x1 is equal to 50 minus 22, so x1 is equal to 28. Any questions about any of those? Like I said, I really wouldn't expect, I mean, I know probably most of you haven't done this stuff in quite a while. I wouldn't really expect most of you to be able to work through all these, but hopefully it's familiar and it kind of, and as I go through the solutions, you're like, oh yeah, I remember doing that, you know. That's about where I hope you are. Okay, well, let's see. So the first thing, before we start talking about physics, really, we're going to talk about measurements and units. I know a lot of people who take this class have taken chemistry, and it's not too much different than the way that you've discussed these same topics in chemistry. So the first topic is measurements and units. And at the basis of measurements and units is the idea that all quantities in physics are measurable. All quantities in any science are measurable. If you have quantities that aren't measurable, you can't do experiments to check them, and if you can't do experiments, then it's not science. So that has to be true. And any measurable value has units. Any measurable quantity for example, a speed of 37 isn't meaningful. Bless you. Because, you know, is it 37 miles per hour, 37 millimeters per day. Those are very different speeds, you know. And every unit is made up of a combination of 4 like basic units. So 4 basic unit types. And really, you could choose any number of 4 quantities as your basic units and derive the other ones from them, but I'm going to choose the one that the set of 4 that people tend to choose as the basic ones. The first one is length. We're always going to use SI units in this class, or at least almost always, so for us, length is going to be meters, but, you know, length could also be miles or feet or light years or a whole bunch of other possible things. The second one is time. The unit for time that we're going to use is seconds. but it could also be hours, microseconds, days. The third one is mass. In SI units, you use kilograms as the measurement of mass. In the imperial system, the British system, you use, the unit is called slugs. You don't hear that very often. Often you hear people talk about pound mass. Although pounds, really pounds are not a unit of mass, they're a unit of force, which is kind of, you know, like how your scale has a, on the back of your scale there's a switch. You can switch between kilograms and pounds. Those aren't really the same thing, you know. It's like switching, it's like your scale switching between kilograms and seconds or something. It doesn't really make any sense. But it makes sense because your scale assumes that you're weighing yourself on Earth, you know. And so like a certain amount, a certain number of kilograms corresponds to a certain force applied by gravity. But like if you took your scale to the moon, you know, your scale would still be accurate, since what your scale measures is the force that you apply to it. Your scale would give you an accurate reading of the number of pounds that you weighed, but it wouldn't give you an accurate reading of your mass in kilograms, because that doesn't change when you go to the moon, you know. And then the last one is charge. I don't know any unit for charge except coulombs, but maybe there are. So that's related to electricity and magnetism. Since, like I said, this class isn't going to do anything with electricity, all of the units that we're going to talk about are going to be combinations of the first three. So like, for example, the SI unit for force is the Newton. And 1 Newton is equal to 1 kilogram meter per second squared. So even though, like, we gave it this name, the Newton, we know it's a measurable quantity, and therefore you have to be able to represent it as a combination of those other four, or for us, the first three. Any questions about that? All right, well, let's stop there, and on Wednesday, we'll start talking about how to do conversions between different types of units that represent the same thing. Like, how do you convert 50 miles? How many kilometers is that? Or, you know, 10 meters per second, how fast is that in miles per hour? That kind of thing.